welcome to a new video. In this video we are going to talk about Pandas series. In simple terms, a series is a one-dimensional labeled array similar to a column in a spreadsheet or a database table. It can hold data of any type, such as integers, floats, strings, or even complex objects. Pandas provides us with a lot of operations to manipulate and analyze series data effectively. The first thing we are going to do is importing the Pandas library. Import pandas as pd. Now we are ready to create our data. In this tutorial we will be working with a series of student scores. Imagine we have a list of students and their corresponding scores in a particular subject. Just going to do a copy paste here and run this. And we have student scores dictionary with Alice 85, Bob 90, Charlie 75, David 92 and Emily 88. Now transforming this into series, scores series is going to be equal to, we are going to use pd.series for transforming it, and we will pass student scores inside of this. Here we define a dictionary called student scores where the keys represented student names and the values represent their scores. We then convert this dictionary into a pandas series using the pd.series function. Now that we have our series, let's display it and see what it looks like. Print scores series. We can see the student names on the left side and their respective scores on the right. Pandas automatically assigns an index to each entry, which we can use to access individual elements or perform various operations. Now let's delve into the sum series operations to extract valuable insights from our data. The first operation we'll explore is the describe method. It provides us with descriptive statistics about our series, giving us a quick overview of its distribution. So let's get this by print scores series.describe, and we are going to get the descriptive statistics here. What we can understand here is, from the count we can see the entry count here. We have 5 entries, and for the mean we can see the average. For the standard deviation we can see the distribution of our data, and for the minimum, quartiles and maximum value we have the maximum grade is 92, the lowest grade is 75, and here it is. This describe method will generate a summary containing statistics such as count, mean, standard deviation, minimum, maximum, and quartiles. This can be particularly useful when dealing with larger datasets. Next up, let's learn how to access individual elements within a series. We can do this in multiple ways, using either label-based or index-based approaches. Let's start by the label-based. For this, we are going to say print scores series, and we need to use like Alice here. With these brackets we can access by label. Also, I'm not going to use any print statements after now, and let's access by index. For this we are going to say scores series, and we can just write the index number of it, and we can run like this. By using the label or the index, we can retrieve specific values from our series. Now we are going to talk about filtering. Sometimes we may need to filter out series based on certain conditions. Pandas allows us to perform conditional filtering effortlessly. For this, we are going to say filtered series and scores series, and for filtering we are going to open brackets, scores series greater than 80. And we are just going to get the grades higher than 80. And let's print this. Also, we can do this without using print filtered series. In this example, we create a new series called filtered series that only contains scores above 80. By applying the condition score series greater than 80, we get a Boolean series. And when we pass this Boolean series inside the square brackets, Pandas returns only the elements that satisfy the condition. Now let's explore some statistical operations we can perform on our series. For example, let's calculate the mean. For this we are going to say scores series.mean, and here it is. And we can calculate the maximum score by scores series.maximum aggregation function here. It's 92. We can do For getting minimum, we can do score series minimum. Oh, let's see the sum of all scores. Score series dot sum. And here are the sum aggregation functions we can use with Pandas series. The sum is 430. We can easily calculate the mean, maximum, minimum, and sum of our series using the corresponding Pandas methods. These statistical operations are incredibly useful when analyzing data. Now we are going to talk about missing data. Dealing with missing data is a common challenge in data analysis. Pandas provides several methods to handle such situations effectively. Let's create a data with missing values. For this, let's import numpy, and we will say missing data series is going to be equal to the pd.series, and we are going to give the array here 90, and let's say numpy.n85, and one more missing data here, and 92. Here it is. Let's see how this looked like. I'm sorry for the typo. Let's fix this, and then we can see we have missing values here. Okay, so what we can do for checking the missing values, we can say missing data series that is null, and we can press enter, and we can see the missing values returned as true. So now I'm going to show you only the dropping the missing values, but you can use methods like fill NA, and you can fill the missing values with mean or median or the option you choose. For dropping these missing values, we can say cleaned series is going to be missing data series that drop NA, and we will print this information. You can see they are dropped. The first and third indexed entries are dropped in this new one. Here we create a series called missing data series with a few missing values represented by numpy.nan. We can check for missing values using the isNull method, which returns a Boolean series indicating which elements are missing. To remove missing values from our series, we can use dropNA method. When working with a large series, it's often helpful to preview a portion of the data. Pandas provides the head and tail methods to display the first or last few elements of a series respectively. Since we are going to keep working with score series, let me also get that one for remembering it. So if you want to display the first three elements, you can say score series.head, and we are going to pass the number that we want to see here, and here it is. We are going to see Alice, Bob, and Charlie. Also, for seeing the last three elements, we can say .tail method, and we are going to pass 3 inside of it, and we can see the Emily, David, and Charlie. By specifying the number of elements within the parentheses, we can control how many rows we want to display. Another common operation is counting the occurrences of unique values within a series. Pandas offers the value counts method to achieve this easily. For this, we are going to say score series dot value counts, and we need to add parentheses, and we can see that how many we have from a value. Like we have one from 85, we have one with 90 value, one with 75 value, and etc. This code will provide a frequency count of each unique score in our series. Sometimes we may need to apply custom functions to our series data. Pandas allows us to do this efficiently using the apply method. For example, let's say we want to double each score. So we can do doubled scores, and it's going to be equal to the score series dot apply, and we are going to use lambda here, x multiplied by 2, and let's print doubled scores. Also, you can change this as 4 inside the function, and you can see it's going to change here, and let's return it back to the doubled version. Here we define a lambda function that multiplies each element of the series by 2. The apply method applies this function to every element in the series, resulting in a new series with updated values. Sorting our series can be immensely useful, especially when dealing with large datasets. Pandas provides the sort values method to sort the series in either ascending or descending order. Let's do the both. Let's say sorted series is going to be equal to the, and we are going to say scores series dot sort values, and let's set ascending to false, which means descending order firstly, and print this. Also, we can set this as true for getting it in ascending order. Here it is. In this example, we sort the series in descending order. For descending order, we can do false here. From highest to lowest score. By default, sort values arrange the series in ascending order. At times, also let me show you that. Let's keep this as default, and you can see it's in ascending order right now. At times, the index of our series may become disordered or have gaps. We can reset the index using the reset index method to create a new index column. It's a really common used method, so I also want to show this at the final. Let's say reset index series is going to be equal to the score series dot reset index, and let's print this. This code will generate a new series with a reset index column. This can be helpful when the index values don't provide meaningful information or need to be rearranged. That was all. Thanks for watching. If you want to see more content related to the data science, you can subscribe to my channel. Have a great day.